Ancient stones hold a silent conversation with the stars. This video reveals how modern technology is finally allowing us to listen, uncovering an astonishing truth. Ancient builders around the world embedded celestial knowledge into their monuments with a precision that rivals our own instruments. You will gain a completely new understanding of human history, one where our ancestors were master astronomers who built in stone what they saw in the sky. We will see how laser scans prove that pyramids aligned with specific stars, and how a jungle city was planned as a map of the cosmos. Why would cultures without written records go to such incredible lengths to track the heavens? What profound secret were they trying to preserve for the future? How does this newfound knowledge change what you thought was possible for ancient people? The idea seemed too fantastical for its time. In the late 19th century, a man named Sir Norman Lockyer gazed at the massive stones of Stonehenge and saw not just a monument, but a machine for watching the sky. He proposed that its great axis was deliberately aligned to frame the sunrise on the longest day of summer. To the established scholars of his day, this was pure fantasy. How could a society they viewed as primitive possibly possess such precise celestial knowledge? Lockyer was largely dismissed, his theories relegated to the fringes of archaeology. Yet in his lonely pursuit, he planted the seed for an entirely new field of study, one we now call archaeoastronomy. This is the science of understanding how ancient peoples perceived the heavens, how they used that knowledge, and the profound cultural role the sky played in their lives. It investigates the purposeful placement of structures to mark celestial events, a practice we term celestial alignment. A stone that precisely frames the solstice sunrise is not just a rock, it is a solstice marker, a permanent clock built by a culture deeply connected to the cycles of nature. The intense skepticism Lockyer faced reveals a crucial truth. It required a complete paradigm shift, a fundamental change in thinking, to accept that our ancestors were not merely surviving, but were sophisticated observers of the cosmos. They encoded their understanding into the very landscape, leaving behind a silent language of stone and sky that we are only now, with our advanced tools, beginning to fluently read. That same silent language of stone and sky remained hidden for centuries, buried under layers of earth and jungle, but a new way of seeing has changed everything. High above the Guatemalan rainforest, a small aircraft flies a precise grid, its instrument firing hundreds of thousands of laser pulses every second toward the ground. This is light detection and ranging, or LiDAR. Most of these lasers hit the dense canopy, but a fraction slip through gaps in the leaves, striking the ground and reflecting back to the sensor. By measuring the minute-time difference for each pulse to return, the system builds an astonishingly detailed three-dimensional map of the terrain below, digitally stripping away the forest to reveal the ghostly footprints of a civilization. Where explorers once saw only an unbroken green carpet, we now see the clear grid of ancient causeways, the outlines of plazas, and the mounds of forgotten pyramids, all without cutting down a single tree. This is non-invasive archaeology, a way of discovering the past without disturbing it. On the ground, another tool peers into the earth itself. Ground-penetrating radar, or GPR, works like a sophisticated echolocator. It sends radar pulses into the soil, and when those waves hit something buried, like a stone wall or a ceremonial platform, they bounce back. By analyzing these returning signals, researchers can create a sonogram of the subsurface, revealing the hidden anatomy of a site. A seemingly empty field might conceal a complex of buildings, or a single standing stone might be shown as the centerpiece of a vast, invisible pattern. These technologies have fundamentally shifted our perspective. We are no longer just studying the monuments we can see. We are discovering the true scale of ancient landscapes, revealing that a lone pyramid was often just the heart of a much larger celestial city. This is how we begin to read the full story, a story written not in ink, but in the purposeful arrangement of earth and stone against the grand canvas of the sky. Dawn breaks over Salisbury Plain, the air sharp and cold. As the first sliver of sun crests the horizon, its golden light pours directly through the heart of Stonehenge, framed with impossible precision between two of the giant Sarsen trilithons. This is no accident of nature. This is the work of master astronomers who carved a calendar from stone. The most famous alignment points to the heel stone, a solitary sentinel standing outside the main circle. On the summer solstice, the longest day of the year, the sun rises directly over this stone, as if the monument itself is reaching out to catch the light. On the opposite side, the so-called slaughter stone, once standing upright, aligns with the winter solstice sunset, marking the year's shortest day and the sun's symbolic death and rebirth. But the celestial knowledge embedded here goes far deeper than the sun. Scattered around the circle are 56 chalk-filled pits known as the Aubrey holes. For generations, their purpose was a complete mystery. Now, researchers propose they formed a sophisticated lunar calculator. The moon's cycle is complex, taking roughly 18.6 years to complete its major wobble in the sky, a pattern known as a lunar standstill. By moving a marker stone from hole to hole each year, the builders could have tracked this long cycle, predicting eclipses and honoring the moon's powerful, rhythmic dance. These are not just theories anymore. Modern theodolite surveys and precise computer simulations have mapped the sightlines to the horizon, confirming that these alignments are mathematically exact. The evidence is now undeniable. Stonehenge is not merely a circle of stones, it is a Neolithic observatory, a permanent record of celestial time built by people who understood the cosmos with a clarity that still commands our respect. The geometric perfection of the Great Pyramid of Giza is a silent shout across 4,500 years. Its four sides are aligned almost perfectly to the north, south, east, and west, with an error so minuscule it defies simple explanation. We are talking about a deviation of less than 1/15 of a single degree. To put that in perspective, that is a finer tolerance than many modern construction projects can achieve without steel or satellites, built with nothing but copper tools and human ingenuity. This is not the work of people who are merely stacking stones. This is the work of master surveyors who understood the earth and the sky with profound intimacy. But the alignments extend far beyond the horizon. Deep within the pyramid's heart, narrow shafts angle upward from the king's and queen's chambers. For a long time, their purpose was a mystery, thought to be merely for ventilation. Then an astronomer named Virginia Trimble made a stunning connection. She proposed that these shafts were not for air but for starlight. Her calculations suggested that around the time the pyramid was built, the southern shaft from the king's chamber pointed directly toward the constellation of Orion, specifically the star Al-Nitak in Orion's belt. Meanwhile, the southern shaft from the queen's chamber was aimed at Sirius, the brightest star in the night sky. In ancient Egyptian beliefs, these stars held immense power. Orion was associated with Osiris, the god of the afterlife and rebirth, while Sirius was linked to Isis, the goddess of magic and healing. The pyramid was not just a final resting place for a pharaoh. It was a machine for the soul, a cosmic launchpad designed to project the king's spirit directly into the celestial realm to join the eternal gods. Modern verification of this theory is breathtaking. Using precise theodolite measurements and accounting for stellar precession, the slow wobble of Earth's axis over 26,000 years that gradually shifts our view of the stars, researchers have rewound the celestial clock. They found that 4.5 millennia ago, these shafts did indeed frame those specific stars with remarkable accuracy. This evidence transforms the pyramid from a simple tomb into a profound statement of belief. It was a gateway to the stars, a permanent bond between a king, his people, and the cosmos they so diligently watched. This level of integration between architecture and astronomy shatters any lingering simplistic view of ancient engineering, revealing a civilization that built its eternity in perfect harmony with the heavens. Far to the north, on a green Irish hillside, another monument captures a single, perfect moment of light. Newgrange is a massive, circular mound older than the pyramids of Giza, and its secret is revealed only for a few precious minutes each year. For 17 minutes at dawn on the winter solstice, a slender beam of sunlight penetrates a specially constructed opening above the entrance, known as a roof box. This shaft of light travels down a 60-foot-long, perfectly dark passageway to finally illuminate the central chamber deep within the heart of the mound. In that silent, darkened space, the sun announces its symbolic rebirth, conquering the longest night of the year. This was not a happy accident. The entire structure, built over 5,000 years ago, is a masterwork of precise engineering and long-term celestial observation. The passage is oriented with such accuracy that even a deviation of a few degrees would mean the sunbeam would miss its target completely. This required the builders to observe the sun's shifting path for generations, understanding its most southerly rising point on the solstice with absolute certainty before committing that knowledge to unyielding stone. They engineered a light show that would outlast millennia. Modern researchers have used sensitive light-level sensors and detailed three-dimensional reconstructions to simulate the solstice event across centuries. These digital experiments confirm the alignment was absolutely intentional, a feat of Neolithic genius. The chamber does not just get a little brighter. The beam forms a vivid, concentrated spot of light that moves dramatically across the floor, a clear and powerful symbol of renewal. For the people who built it, this was likely the center of their spiritual world. They invested immense communal effort to create a permanent link between their world of the living, the realm of their ancestors within the mound, and the life-giving power of the sun. This was a sun temple, a place where the cosmos itself performed a sacred ritual once every year, guaranteeing the cycles of nature would continue. While the stones of Newgrange captured a single beam of light, the Maya engineered a spectacle of shadow and motion. In the heart of the Yucatan, as the sun sets on the spring equinox, a miracle of ancient design unfolds at the Pyramid of El Castillo. The dying light strikes the western balustrade of the northern staircase, casting a series of 7 interlocking, triangular shadows down the steps. To the awe of the gathered crowd, these sharp, dark shapes connect with the giant stone serpent heads at the base, forming the undulating body of a massive, slithering feathered serpent descending from the heavens to the earth. This is the divine Kukulkan, the plumed serpent god, making his annual descent. The precision required to achieve this illusion is staggering. The pyramid is a perfect solar calculator in stone. Each of its 4 sides has 91 steps. When you add the single step of the top platform, you get 365, one for each day of the solar year. This was not a hidden secret, but a public declaration of the Mayas' complete command over time itself. Could this breathtaking effect truly be intentional, or is it just a happy coincidence of shadow and stone? Modern digital modeling provides the definitive answer. Using architectural software and precise solar tracking algorithms, researchers have recreated the equinox event. They found that the angle of the staircase, the profile of the balustrades, and the placement of the serpent heads are all geometrically interdependent. The simulation proves that even a slight deviation in any one of these elements would cause the serpent's body to break apart or fail to align. This was a deliberate, engineered phenomenon, a testament to a civilization that wove its cosmology directly into the fabric of its cities. The pyramid was more than a temple. It was a civic clock and a celestial theater, uniting the entire community in a shared witness of cosmic order, a bond between the gods, the sky, and the people below. Yet across the channel, a different kind of mystery unfolds in the French countryside. The Carnac alignments are not a single monument, but a sprawling, almost chaotic landscape of stone. Over 3,000 weathered megaliths stand in silent, parallel rows, stretching for miles across the moors of Brittany. Walking among them is a disorienting experience. From the ground, the patterns feel immense and confusing, a giant's game of dominoes left frozen in time. For centuries, their purpose was anyone's guess. Were they a mustering field for a mythical army turned to stone, a sacred pathway for religious processions? The sheer scale defied simple explanation. But from a new perspective, a breathtaking order emerges. When researchers began using drones to capture thousands of overlapping aerial photographs, a technique called photogrammetry, they could stitch together a perfectly scaled digital model of the entire site. They combined this with Geographic Information Systems, or GIS, software to analyze the alignments on a scale never before possible. Suddenly, they saw what was invisible from the ground. Certain long, straight rows of stones were not pointing randomly. They were aimed directly at the horizon locations where the moon would rise or set during its most extreme positions in its long, 18.6-year cycle, the major lunar standstill. Other rows seemed to frame the sun at the solstices. This was not a single observatory. It was a colossal calendar carved into the landscape itself. The implications are staggering. This was a communal project of almost unimaginable effort, coordinated over generations, to create a permanent map of the cosmos. It speaks to a society deeply unified by a celestial vision, one that moved mountains, or at least thousands of stones, to synchronize their world with the rhythms of the sky. What could possibly compel an entire culture to undertake such a monumental task? High on a razorback ridge in the Andes, the stone citadel of Machu Picchu feels less like a city and more like a part of the sky itself. Here, the Incas did not merely build with the land, they built as an extension of it, weaving their architecture into the sacred peaks to create a living bridge to the heavens. At the heart of this celestial design stands the Intihuatana, an exquisitely carved granite pillar whose name means the hitching post of the sun. This was no simple monument. During the equinoxes, at the precise moment of solar noon, this masterfully shaped stone casts no shadow at all. The sun stands directly overhead, as if tethered to the earth, its power captured and held in a moment of perfect balance. This was the ultimate act of cosmic engineering, a ritual frozen in stone to ensure the sun's continued journey across the sky. The Incas believed their ruler was the direct descendant of the sun god, Inti, and their entire empire was sustained by his divine light. Letting the sun stray from its path was unthinkable, and the Intihuatana was their anchor, a spiritual instrument of profound importance. Modern GPS surveys and astronomical software have analyzed this precise alignment, confirming that the stone's angles are not random. They are calculated to interact with the sun's position with breathtaking accuracy, a feat that required deep, generational knowledge of solar movements. This was a civilization that spoke to the gods through geometry and shadow. Just below the Intihuatana rests the Temple of the Sun, a semi-circular wonder of masonry, built around a natural outcrop of bedrock. One of its trapezoidal windows is perfectly framed to capture the first rays of the rising sun on the June solstice, the shortest day of the year in the southern hemisphere. As dawn breaks, a blade of light slices through this sacred aperture, striking a specific mark on the polished stone floor within. This was the sun's symbolic return, a reassurance that the seasons would turn and life would renew. The entire city is a masterpiece of this intentional placement. Researchers using satellite imagery and three-dimensional modeling have found that major structures align not only with solar events but with the surrounding Apus, the revered mountain spirits, and key stars. They did not flatten the mountain to build their city. They sculpted it into a cosmic diagram, a map of their spiritual universe where every stone, every building, and every vista was a conscious reflection of the celestial order. In the silence of the Andes, the stones of Machu Picchu still whisper this ancient truth, that the sky above and the earth below are one single, interconnected whole. While the stones of Machu Picchu spoke to the gods, another civilization was quietly building a different kind of monument, one not of rock but of written numbers. In the dust of Mesopotamian ruins, archaeologists unearthed thousands of clay tablets inscribed with the sharp, wedge-shaped marks of cuneiform. Among these, one collection stands apart, a series of 70 tablets known as Enuma Anu Enlil. This was not an epic poem or a king's decree. It was a scientific archive, a meticulous record of celestial movements spanning centuries. The Babylonians were not just watching the sky, they were logging it, creating the first known long-term data set in human history. They tracked the cyclical appearances and disappearances of the planet Venus with the same care a modern scientist would track a comet. They recorded lunar eclipses, noting their timing and duration, and charted the slow, wandering paths of the planets against the fixed backdrop of stars. This was astronomy divorced from architecture, a pure pursuit of pattern and prediction etched into soft clay that hardened into a permanent record. Their goal was not merely spiritual, it was profoundly practical, believing that the motions of the heavens directly influenced events on Earth, from the fate of kings to the success of the harvest. To unlock these patterns, they had to become mathematicians. They observed that celestial events, like the cycle from one full moon to the next, did not fit neatly into their base 60 numerical system. So they developed something extraordinary, a mathematical technique we now call linear zigzag functions. This was not simple counting. It was a way of modeling the increasing and decreasing speed of the moon's movement across the sky, creating a predictive algorithm that could forecast lunar phases with remarkable accuracy. They essentially invented an early form of calculus to describe the cosmos. The legacy of this work is almost immeasurable. Centuries later, this very data, these Babylonian observational records and mathematical techniques traveled west. They were studied and absorbed by Greek astronomers like Hipparchus and Ptolemy, forming the essential bedrock upon which all of Western astronomy was built. Modern scholars have used powerful computational analysis to verify the precision in these ancient tables, running the Babylonian numbers through our own digital models. The results are stunning. Their predictions for lunar events often align with modern astronomical retrocalculations to within a matter of hours. This reveals a profound truth. The ancient pursuit of celestial knowledge was a dual legacy, expressed both in the epic scale of monuments that touch the sky and in the quiet, diligent work of scribes who archived the stars. One was a public prayer in stone, the other was a private conversation with the universe, written in lines of data on a tablet that could fit in the palm of your hand. Deep in southeastern Turkey, a hill known as Göbekli Tepe quietly dismantles our oldest assumptions about human history. This sprawling complex of carved stone rings and massive T-shaped pillars is not just old, it is staggeringly ancient, built over 12,000 years ago. That is 6,000 years before the first stone was laid at Stonehenge, and 7,000 years before the Great Pyramid of Giza. What makes this date so revolutionary is the world these people inhabited. They were not farmers living in settled villages. They were hunter-gatherers, nomadic people who should have been, by every traditional model, focused solely on survival. Yet they came together to erect what is considered the world's first known temple, a project requiring a sophisticated level of social organization and skilled labor that we never dreamed was possible in that era. The pillars themselves are a gallery of prehistoric art covered in finely carved reliefs of animals. There are scorpions, foxes, vultures, and lions. For a long time, these were seen as powerful spiritual symbols or totems of different clans, but a compelling new theory suggests they might be something else entirely, a Stone Age star chart. Perhaps these animals were not just earthly creatures but celestial ones representing constellations in the night sky. The scorpion could be Scorpius, the fox might be a forgotten constellation, and the vulture could be our modern-day Lyra. This is not merely a symbolic interpretation. Some researchers, using sophisticated software that accounts for stellar precession, have proposed that the entire layout of Göbekli Tepe was astronomically deliberate. They suggest that specific enclosures, defined by their central pillars, were aligned to track the rising of key stars like Sirius, the brightest in our sky, or the stars of the Cygnus constellation. If even partially correct, this idea is explosive. It means that systematic, precise observation of the heavens may not have been a product of civilization, but its very cause. The impulse to build these monumental structures, to gather and coordinate on a massive scale, might have been driven by a shared, sacred need to understand and commune with the cosmos. Göbekli Tepe stands as a silent challenge, forcing us to ask if the seeds of astronomy, and indeed of civilization itself, were planted not in the fertile fields of farmers, but in the starlit minds of hunters who first looked up and saw a story written in the sky. High on a sun-baked butte in New Mexico's Choco Canyon, a secret was kept for centuries. Upon a sheer rock face, a spiral petroglyph was carved by the ancestral Pueblones, a people once known as the Anasazi. For most of the year, it is simply ancient art, but on the morning of the summer solstice, a sliver of light appears. This is the sun dagger. 3 massive, carefully positioned stone slabs act as a celestial aperture, channeling the dawn light into a sharp, brilliant blade that slices directly down the center of the spiral. At the precise moment of solstice, the dagger perfectly bisects the carved circle. Then, months later, on the equinox, the sun creates 2 daggers of light that gently bracket the spiral, one on each side. This was not a random play of light and shadow. It was a sophisticated solar calendar etched into the living rock, a way for a culture to mark the turning of the seasons with absolute certainty. Could a natural arrangement of rocks produce such a specific and repeated effect? Modern research provided the definitive answer. Using time-lapse photography and advanced solar alignment software, scientists meticulously modeled the interaction of the slabs and the sun's path. Their digital reconstructions proved that the placement of those 3 specific slabs was no accident. The angles were too perfect, the resulting light patterns too deliberate. The entire formation functioned as a complex astronomical instrument, a permanent sundial designed to announce the most important days of the year. Tragically, this delicate masterpiece could not withstand the modern world. In the 1980s, concerns arose that the slabs had shifted, possibly due to erosion or the impact of researchers and their equipment. The precise alignments were at risk of being lost forever. To protect the site from further damage, public access was permanently closed. We can no longer witness the sun dagger in person, yet its legacy endures as a powerful reminder. It shows us that profound astronomical knowledge was not confined to the Great Pyramids or sprawling stone circles. It could be found in a single, elegant interaction of rock and light on a canyon wall. This was a universal human impulse, the drive to read the story of time itself in the unwavering motion of the sun. The stones of Angkor Wat hold a silent dialogue with the cosmos. As dawn breaks on the spring equinox, the sun ascends in perfect alignment with the temple's central tower, a pinnacle representing the mythical Mount Meru, the axis of the Hindu universe. This is not a chance occurrence. It is the opening note of a grand architectural symphony, a deliberate act of creation that transformed a sprawling temple into a scale model of the cosmos itself. The entire complex is a mandala, a sacred geometric diagram of the universe, rendered in sandstone and laterite. Its vast moat represents the cosmic ocean, while its concentric galleries and towers mirror the celestial realms surrounding the world's spiritual center. This was a place where the divine and the earthly met, where kings could walk through a model of the heavens they believed they ruled by divine right. The sheer scale of this vision becomes clear when you examine the temple's very dimensions. The lengths of the galleries and the intricate bas-reliefs that adorn them are not arbitrary. Scholars suggest these measurements correspond to the vast cycles of time in Hindu cosmology, the 4 yugas which span millions of years. A walk through the temple was a journey through cosmic time, a physical manifestation of beliefs about creation, preservation, and dissolution. For generations, our understanding of this celestial city was limited to the temple proper, a magnificent island in a sea of jungle. But modern technology has pulled back the green veil, revealing the true, breathtaking scope of the ancient Khmer vision. Recent LiDAR surveys have scanned the area around Angkor, digitally erasing the dense forest to expose the ghostly grid of a vast urban sprawl. The data revealed canals, roads, and mounds that formed a precise urban plan, aligned to the cardinal directions with an accuracy that rivals modern city planning. This was not just a temple complex, it was an entire metropolis engineered as a single, gigantic cosmic diagram. The entire city of Angkor, from its central temple to its outermost suburbs, was conceived as a single act of cosmic ordering, a mandala made real on an almost unimaginable scale. This discovery fundamentally changes the story. It reveals a civilization that did not just build a temple to honor the gods, but engineered an entire landscape to reflect the perfect, eternal order of the universe. A corroded lump of bronze and wood, resting for 2,000 years at the bottom of the sea, held a secret that would rewrite our understanding of ancient genius. This is the Antikythera Mechanism, discovered in a Roman shipwreck off the coast of Greece at the dawn of the 20th century. For decades, it was a curiosity, a mysterious crusted object that seemed to have a few gear wheels embedded within it. It was only when researchers began to peer inside with advanced X-ray tomography that the truth emerged. This was not a simple navigational tool or an ornate trinket. It was an intricate, hand-powered mechanical computer, a device of staggering complexity built in the 2nd century before the Common Era. The three-dimensional models created from this high-resolution scanning revealed a labyrinth of interlocking bronze gears, precisely cut and arranged in a system that mirrored the mathematical ratios of the cosmos itself. You could turn a hand crank on the side, and through a series of differential gears, a complexity not seen again until the 19th century, dials and pointers would move across multiple concentric scales. One dial tracked the metonic cycle, a 235-month period that synchronizes the solar and lunar calendars. Another predicted the dates of lunar and solar eclipses, even hinting at their likely appearance and color based on celestial patterns. A small, rotating ball, half silvered and half black, showed the exact phase of the moon on any given date. It could even model the irregular orbit of the moon, accounting for its variable speed across the sky, a subtlety known as lunar anomaly. This was not just a model of the sky, it was a predictive engine. Its existence proves that the ancient Greeks had moved far beyond simply observing the heavens. They had internalized its mathematics so completely that they could translate celestial motion into mechanical poetry, building a portable universe inside a box. This artifact bridges the immense gap between the stationary, architectural astronomy of pyramids and stone circles and the dynamic, personal computation of a handheld device. It showcases a different kind of precision, one that is not fixed in the landscape but rotates in the palm of your hand, a miniature cosmos crafted from bronze and pure intellect. The intricate bronze gears of the Antikythera Mechanism represent one way of knowing the sky, a path of mechanics and mathematics. But there is another way of knowing, one that is not locked in a box or carved in stone, but sung into existence across generations. In the vast Australian outback, an Aboriginal elder gazes up at the shimmering river of the Milky Way. Where we might see a random scattering of stars, she sees the great emu in the sky. This is not a constellation of bright stars, but a dark constellation, its form defined by the sprawling, opaque dust lanes that blot out the starlight behind them. The body of the celestial emu stretches across the heavens, and its orientation changes with the seasons. When the emu appears to be sitting down on the horizon in the early evening, the elder knows the time is right. It is the season when the real, earthly emus are laying their eggs. This celestial signal is a direct, practical guide for life, dictating when to gather this crucial food source. This living knowledge is the heart of ethnoastronomy, the study of how contemporary indigenous cultures understand and use the sky. It provides the vital cultural context that our silent stones can no longer speak. For these cultures, astronomical precision was never just about measurement for its own sake. It was about weaving the cosmos directly into the fabric of daily existence, into law, ceremony, and the very rhythm of survival. The position of the emu in the sky is a chapter in a vast oral encyclopedia of knowledge that connects animal behavior, plant cycles, and weather patterns into a single, holistic understanding of the world. Modern ecological science is only now beginning to catch up, using satellite data and long-term studies to verify the intricate seasonal connections that indigenous knowledge systems have held for millennia. This perspective reveals a profound truth. The ultimate goal of watching the heavens was not merely to predict, but to participate, to live in conscious, respectful harmony with the cycles dictated by the cosmos. It was a deeply integrated science, one where the sky was not a distant clock to be measured, but a living story to be followed, a story that guided every aspect of life on the earth below. This slow, cosmic drift holds the key to unlocking the true age of ancient alignments. Our planet does not spin perfectly upright like a top. Instead, it wobbles very slowly over a cycle of 26,000 years. This is precession, a gradual shift in the orientation of Earth's axis. Imagine a spinning gyroscope slowly tracing a circle as it rotates, its top point moving in a wide, lazy arc. Earth's North Pole does the same, pointing at different stars over millennia. Today, we have Polaris, the North Star, but 4,000 years ago, the star Thuban in the constellation Draco held that position, and in 12,000 years, it will be the bright star Vega. This wobble also causes the position of the equinoxes, the points where the sun crosses the celestial equator, to slide backward along the ecliptic path by about 1 degree every 72 years. This means the entire celestial coordinate system is in constant, slow motion. A stone pillar perfectly aligned with the rising sun on the spring equinox 5,000 years ago would see that sunrise occur in a slightly different position today. The alignment appears broken, not because the builders made an error, but because the sky itself has shifted. This is where modern technology becomes our time machine. Astronomers can use sophisticated software like the program Stellarium to digitally rewind the sky. By inputting the exact coordinates of a monument and then reversing the clock, accounting for every minute of precessional drift, they can recreate the night sky exactly as the builders saw it. When a claimed stellar alignment, like a shaft in a pyramid pointing to a specific star, lines up perfectly in this ancient simulation, the evidence becomes compelling. It moves from a possibility to a high probability. This ability to test alignments across time is what separates genuine celestial architecture from mere coincidence. It provides a chronological anchor, allowing us to say with confidence that a monument was not only built to watch the stars, but was built at a specific moment in our planet's long cosmic dance. Of course, with thousands of stones scattered across a landscape, a few are bound to line up with something in the sky by pure luck. This is the first and most crucial objection any serious researcher must confront. It is the ghost of coincidence that haunts every ancient site. To silence this ghost, archaeoastronomy had to borrow a powerful tool from modern science, the statistical null hypothesis. The process begins with a simple, skeptical question. What would we expect to see if the builders had no astronomical intention at all? Researchers feed the exact location of a site like Carnac into a computer, along with the positions of key celestial events over centuries. The software then generates thousands of completely random virtual versions of the site, scattering the same number of stones across the same terrain with no purposeful alignment. It is a digital lottery of chance arrangements. The result is a clear statistical baseline. In these random models, a few alignments will occur, but they are scattered and inconsistent. When scientists then overlay the real, physical alignments of Carnac onto this model, the difference is undeniable. The concentration of stones pointing to the solstice sunrises and the moon's extreme standstills is not a sparse scattering. It forms a dense, coherent pattern that the random simulations rarely, if ever, produce. The probability that this specific, repeated clustering of alignments happened by accident is astronomically low. This rigorous methodology separates a meaningful signal from the noise of our own pattern-seeking brains, a tendency known as pareidolia, where we might see a face in a cloud or a dragon in a star cluster. By proving that the evidence vastly exceeds the expectations of random chance, this analysis elevates the entire field. It transforms a captivating idea into a statistically verified fact, confirming that the silent stones were indeed speaking a deliberate, complex language of the sky. The weight of a single blue stone destined for Stonehenge is a staggering physical fact. Imagine the immense effort required to move a 50-ton block of rock over 150 miles of rugged, prehistoric terrain. This was not a task for a few dozen people. It was a monumental undertaking that demanded the coordinated labor of an entire society, a testament to a shared vision powerful enough to move literal mountains. The journey likely began in the Preseli Hills of Wales, where the unique bluestone was quarried. From there, the most plausible route would have combined human ingenuity with the landscape itself. We can envision teams using wooden sledges, massive log frames that would slide over a track of greased timbers. Others may have employed rollers, constantly moving logs from the back of the sledge to the front in a painstaking, rhythmic procession that inched the stone forward mere feet each day. For the long stretches, water would have been their greatest ally. Rafts, or perhaps the stone itself lashed beneath buoyant logs, could have been floated along rivers and coastal waters, a slightly less grueling but no less dangerous method of transport. This was not just about getting a rock from one place to another. It was an engineering project that spanned generations. The knowledge of how to move such a mass had to be passed down, the route maintained, and the laborers fed and sheltered. This implies a staggering level of social organization, a hierarchy of engineers and foremen who could plan and execute a project whose completion they might never live to see. How do we know any of this is possible? The proof comes from the field of experimental archaeology, where modern teams using replicas of ancient tools and techniques have attempted to recreate these feats. They have carved stones with mauls, transported multi-ton blocks on sledges, and discovered the precise number of people and the exact amount of animal fat needed to lubricate the tracks. These are not just academic exercises, they are physical proofs of concept demonstrating that with enough coordinated human effort, the impossible becomes achievable. The true marvel, then, is not found in any single tool or technique. It is found in the collective will of a people. The astronomical precision of Stonehenge rests upon a foundation of sheer human determination. The wisdom to chart the stars was matched only by the willpower to haul their earthly representatives across a continent, stone by agonizing stone. This universal drive to build in harmony with the heavens points to a profound human question. Why did cultures separated by oceans and millennia share this singular celestial focus? The answer lies in a powerful combination of practical necessity and deep spiritual yearning. For societies taking their first steps into agriculture, the sky was the ultimate almanac. Knowing precisely when the rains would come or when the river would flood was a matter of survival. The solstices and equinoxes were not abstract astronomical events. They were critical deadlines signaling when to plant seeds or harvest crops. The unwavering predictability of the sun and stars provided a reliable framework for time itself, a cosmic clock that never failed. This created a comforting order in a world that could often feel chaotic and unpredictable. Beyond the practical, the sky was a canvas for the divine. The sun was a life-giving god, the moon a powerful cyclical force, and the wandering planets were seen as celestial messengers. By building structures that captured the light of these deities at key moments, our ancestors were not just observing, they were communing. They were forging a permanent link between their community and the cosmic powers they believed governed their fate. A king or priest who could demonstrate a unique connection to these forces, who could predict an eclipse or command the sun to return, wielded immense authority. Their power was legitimized by the heavens themselves. In essence, these monuments were an act of cosmic mirroring. By recreating the order of the universe here on Earth, they were attempting to harness its stability and power, to bring the divine down to earth and anchor it in stone. This was a fundamental human impulse to find our place in the grand story of existence, to build a bridge between the earthly and the eternal that would stand long after its builders were gone. From high above, the earth itself becomes a canvas. The parched plains of Peru hold one of the planet's most enigmatic artworks, the Nazca lines. From the ground, these are merely shallow grooves in the reddish soil, confusing scratches that wander aimlessly. But ascend to the vantage point of a satellite or a low-flying aircraft, and these lines transform into a breathtaking gallery of giant geometric shapes, a colossal hummingbird, an intricate spider, and a towering humanoid figure known as the astronaut. Their full, majestic forms are only visible from the sky, a perspective utterly impossible for their creators to physically achieve. This same bird's eye view reveals the Uffington white horse in England, a stylized equine figure carved into a chalk hillside so vast that its sweeping lines can only be truly appreciated from the air. These are not just artworks, they are landscape-scale monuments designed to be seen by powers in the sky, whether gods, spirits, or ancestors. The discovery of such figures forced a profound question. How and why would ancient peoples create art they could never fully behold? The answer seems to lie in the act of creation itself, a devotional offering meant for a celestial audience. But satellite technology has moved far beyond simply photographing what we can already see from a plane. Modern remote sensing satellites are equipped with multispectral sensors that see far more than our eyes can perceive. They detect subtle differences in light wavelengths reflected by the Earth, revealing secrets hidden just beneath the surface. A buried stone wall or a filled-in ditch will retain moisture differently than the surrounding soil. This affects how plants grow above it. Lush, healthy crops might trace the outline of a hidden moat, while stunted, stressed vegetation could reveal a buried stone pathway. From space, these patterns are invisible to us, but to a satellite sensor, they paint a clear picture of what lies below. This is how researchers have discovered massive, previously unknown Cursus monuments in Britain, enormous Neolithic enclosures that form long, processional avenues across the landscape. These are not isolated temples, but parts of a vast, interconnected ritual complex, linking burial mounds, stone circles, and ceremonial pathways into a single, gigantic astronomical diagram. Our understanding is expanding from studying solitary sites to mapping entire sacred geographies. We are no longer just looking at monuments, we are reading the hidden sentences and paragraphs that connect them, realizing that a single standing stone was often just one word in a much longer story written across the earth itself. Ancient stones can also sing. Beyond the silent alignments and carved calendars lies an entirely different sensory dimension, the world of sound. This is the focus of archaeoacoustics, a field that listens to the past by studying the sonic properties of ancient spaces. At the Hal Saflieni Hypogeum in Malta, an underground labyrinth carved from solid rock over 5,000 years ago, researchers made an astonishing discovery. A specific chamber, known as the Oracle Room, resonates at a powerful low frequency of 110 Hz. When a person speaks within this space, their voice is transformed. It does not merely echo, it amplifies and reverberates in a way that seems to fill the entire body, creating a visceral, almost physical sensation. This is not a random acoustic effect. Studies in modern neuroscience have shown that exposure to this specific frequency can produce shifts in brain activity, sometimes reducing activity in the language centers of the brain and potentially facilitating a more receptive, meditative state of awareness. Could the builders have intentionally sculpted this chamber to produce such an effect? The possibility invites a profound speculation. Perhaps these resonant frequencies were chosen to mimic a perceived music of the spheres, a celestial harmony believed to emanate from the movements of the planets. Or maybe, during rituals timed to an eclipse or a solstice, the combination of chanting, drumming, and the room's own natural resonance was used to guide participants into a trance state, a heightened form of consciousness where the boundary between the earthly and the cosmic seemed to dissolve. Modern researchers now use sophisticated audio analysis equipment, like impulse response microphones and three-dimensional sound modeling software, to map the acoustic fingerprints of these ancient sites. They are finding that the experience was never meant to be solely visual. It was a full multi-sensory immersion. The precise alignment of a passageway to catch the dawn light would have been accompanied by the resonant hum of the stone itself, a chord struck by the universe and answered by the earth. In this complete experience, the visitor did not just see the cosmos, They felt its vibration, connecting with the heavens through the very core of their being. The sky our ancestors observed was a different theater entirely. Modern city lights wash out the stars, but millennia ago, the night was a profound, velvety black, punctuated by a brilliance we can now only find in the most remote deserts. This was their constant reality, a canvas where even the faintest celestial event was starkly visible. Paleoclimatology, the study of ancient climates, provides the evidence for this pristine environment. Ice core samples from glaciers and sediment layers from lake beds act as a historical record, capturing tiny bubbles of ancient air and particles of atmospheric dust. This data tells a story of clearer, drier atmospheric conditions in many regions during the ages when these great monuments were raised. Without the haze of industrial pollution, the horizon was a sharp, clean line, and the stars did not just twinkle, they blazed. This clarity transformed the act of observation. Consider the heliacal rising of a star, its first appearance in the dawn sky after a period of invisibility. For us, this is often a subtle event lost in the glow of sunrise, but under a truly dark sky, that single, defiant point of light emerging beside the sun would have been a dramatic, unmistakable herald. It was a signal that could mark the beginning of a season or the start of a sacred ceremony. This environmental context is not a minor detail. It is fundamental to understanding their achievements. We must strip away our own light-polluted experience to appreciate the raw data they had to work with. Their naked eye was a more powerful instrument than we can easily comprehend. Their night sky a dynamic, living tapestry. They were not struggling to see faint clues. They were reading a brilliant, obvious script written across the heavens, a script we have since dimmed with our own progress. This new ocean of digital data is so vast it can no longer be navigated by human eyes alone. We have mapped entire jungles and scanned countless square miles of terrain, creating immense archives of information. The next great leap requires a new kind of explorer, one that does not tire and can process millions of data points in the blink of an eye. This is where artificial intelligence enters the story, not as a replacement for human curiosity, but as its most powerful amplifier. Imagine training a machine learning algorithm, a form of artificial intelligence, on every known celestial alignment at sites like Stonehenge and Choco Canyon. The algorithm learns the subtle geometric and spatial fingerprints of intentional astronomical design. Once trained, this digital detective can be unleashed on the massive datasets from LiDAR, ground-penetrating radar, and satellite imagery. It does not just look for shapes, it searches for relationships, scanning thousands of sites simultaneously for the faint, mathematical ghost of an alignment that a human researcher might miss. It could, for instance, analyze the orientation of a newly discovered earthen mound in the American Midwest and flag it as a potential solstice marker with a high degree of probability, long before a team ever sets foot on the ground. This moves us from reactive discovery to predictive science. The ultimate goal is not merely to find what we have already built, but to understand the mind of the builders themselves. An advanced AI system could one day generate dynamic models of how a culture's celestial knowledge evolved over centuries. Did their focus shift from lunar cycles to solar cycles? Did their alignment targets become more precise over time, reflecting generations of accumulated observation? The AI could trace this intellectual journey through the stones, revealing a living, growing science. Most thrillingly, it could begin to suggest the locations of entirely undiscovered monuments. By analyzing the known patterns of a civilization, the typical distances between markers, and the preferred alignment to a sacred mountain or star, the system could highlight areas on a map and say, based on everything we know, there is a high probability you will find something meaningful here. This transforms our relationship with the past. We are no longer just students of history, we are becoming active partners in a conversation with it, using the tools of tomorrow to ask new questions of our oldest stones and finally hear the answers they have been holding for millennia. Yet this journey of discovery is not without its own complex debates and necessary cautions. Within academic circles, a long-standing tension exists between two competing ideas. On one side is the diffusionist theory, which suggests that advanced astronomical knowledge originated from a single, perhaps lost, civilization and then spread across the world. On the other is the independent invention theory, which argues that different cultures, separated by vast oceans, each developed their own sophisticated understanding of the sky based on their unique environments and needs. The evidence increasingly supports the latter view. While the shared human mind led to similar conclusions, the specific expressions were beautifully distinct. The Maya built serpent shadows, the Egyptians aligned shafts to specific stars, and the builders of Carnac mapped the moon with thousands of stones. This points not to a single teacher, but to a universal human capacity for observation and genius, a powerful reminder of our shared intellectual heritage. This exploration also carries a profound ethical weight, especially when it involves the sacred sites of living indigenous cultures. When a research team arrives with laser scanners and ground-penetrating radar to study a location that is still a place of worship and cultural memory, critical questions must be asked. Who truly owns the data that is collected? Does publishing precise GPS coordinates online, while valuable for science, inadvertently expose a sensitive site to irreparable damage or disrespect? The balance is delicate. It requires a partnership where scientific inquiry is guided by the deep, enduring knowledge of the people for whom the sky and the earth remain inseparable parts of their identity and spirituality. The goal must shift from simply extracting information to fostering a respectful dialogue, ensuring that technological advancement does not come at the cost of cultural preservation. We must also guard against a persistent temptation, often called paramediosy. This is the urge to explain away ancient marvels by attributing them to lost super-civilizations, alien visitors, or mystical forces. While these ideas can be captivating, they ultimately do a great disservice to our ancestors. They strip away their agency and their intellect, suggesting that humanity was incapable of such achievements on its own. The real wonder is not in the fantastical, but in the tangible. It is in the calloused hands that moved 50-ton stones, the patient minds that tracked the moon's slow wobble over lifetimes, and the brilliant cultures that encoded their universe into their architecture. The true story, verified by statistical analysis and digital reconstruction, is far more inspiring. It reveals the extraordinary capabilities of human beings, our innate drive to understand our place in the cosmos, and the enduring legacy we can build when we look up at the stars with curiosity, determination, and respect. This emerging picture completely rewrites the story of our past. For too long, the narrative of prehistory was one of simple survival, of societies too preoccupied with basic needs to pursue abstract science. The evidence now tells a different tale, one of profound intellectual ambition. These ancient builders were not primitive mystics. They were the physicists and astronomers of their age, conducting long-term experiments and recording their findings not on paper, but in the most durable medium they had, the Earth itself. Their great monuments were not just tombs for kings or temples for rituals. They were multi-functional institutions, serving as universities where celestial knowledge was taught through architecture, as agricultural calendars that dictated the seasons for planting and harvest, and as profound cosmic interfaces where a community could physically interact with the forces that governed their world. The stones were their textbooks, the alignments their equations, and the cyclical events in the sky their laboratory results. This was a sophisticated, applied science, deeply woven into the cultural and spiritual fabric of their lives. With our satellites and lasers, we have finally been given the tools to translate this ancient language. We are no longer just gazing at ruins, we are reading a vast, interconnected library written in stone and landscape. Each confirmed alignment is another chapter recovered, revealing a universal human drive that transcends time and culture. It is the quest to answer our most fundamental questions. Where do we come from? What is our purpose? How does our world fit into the grand scheme of the cosmos? This quest did not begin with modern telescopes. It began when the first human looked up at a star-filled night and felt a deep, compelling need to understand. In recognizing the scientific genius of our ancestors, we are not just learning about them, we are rediscovering a fundamental part of ourselves, a shared legacy of curiosity that connects us directly across the millennia. From the solstice alignment at Stonehenge to the star shafts of the Great Pyramid, we have seen how modern technology acts as a universal translator for the silent language of ancient stones. These tools have allowed us to hear a conversation that has been waiting for millennia, a dialogue between human ingenuity and the cosmos. The key takeaway is a profound new respect for the intellectual achievements of our forebears. They were not primitive people merely struggling to survive. They were master astronomers and engineers who tracked the heavens with nothing but their eyes, their minds, and an unwavering determination to build for the ages. They solved complex mathematical problems and executed architectural plans on a scale that still defies easy explanation, all to encode their understanding of time and space into the landscape. This journey through time and stone reminds us that the drive to understand the cosmos is a defining human trait, a shared legacy of curiosity that connects us directly across the centuries. It is a story that belongs to all of us. If this exploration of our shared astronomical heritage has inspired you, we would love to hear your thoughts in the comments below. What ancient site resonates most with your sense of wonder? And for more journeys to the frontiers of history and science, please subscribe. The past still has countless secrets left to